Choosing a data display. All right, so as always, here's the state standards and success criteria. To be successful, you need to be able to classify data as qualitative or quantitative, create an appropriate data display and explain the choice of display, and identify misleading data displays. All right, so here's your 3 vocabulary words that you need to know and become familiar with. And this is your key idea. So today the vocab is your key idea. Basically, if you understand the definitions of these terms, you should be able to easily identify what the answers are for the problems that we're working on today. So qualitative data, this is also known as categorical data, consists of labels or non-numerical entries that can be separated into different categories. When using qualitative data, operations such as adding or finding a mean do not make sense. All right, quantitative data consists of numbers that represent counts or measurements. And again, you can see that is copied over here under your vocab, very important. And then one more vocab is a misleading graph is a statistical graph that is not drawn appropriately. So it can be misleading if the graph is not drawn appropriately. So maybe the scale is off, or maybe, I don't know, maybe it's just there's stuff on the graph that causes it to be misleading. And we will look at some examples of that today. All right, example 1, classifying data. Tell whether the data are qualitative or quantitative. All right, study tip. Just because a frequency count can be shown for a data set does not make it quantitative. A frequency count can be shown for both qualitative and quantitative data. All right, so just be aware. You need to know the definitions, and if you do, hopefully it will be easy. So remember, quantitative is the one where there's going to be numbers and there's going to be some kind of numbers that you can actually compare and use to generate some kind of data. Qualitative is just sets of colors or sets of different things that don't have anything to do with finding the mean or the average or anything like that. All right, so A, prices of used cars at a dealership. So would that be qualitative or quantitative? Well, prices are numeric. So in this case, the data is quantitative. So you could take all the prices of the used cars at the dealership and find the average or the range or whatever you wanted to do with that. So that would make this one a quantitative data set. B part, jersey numbers for a basketball team. All right, jersey numbers. You're talking about numbers on their jersey. So you are looking at numbers, but there's no reason to get an average. There's no reason to do anything with those numbers. So those numbers are basically used as just a label. It labels the jerseys so each player knows which jersey is theirs. So it doesn't make sense to compare them. And a lot of times, kids get to pick their jersey number. So that's not going to be something you're going to use to get an average or anything like that. So in this case, the data is qualitative. All right, qualitative. Again, we're not looking to compare the numbers. All right, C part, lengths of songs played at a concert. All right, so the song lengths are numeric measure. It could be 2 minutes long, 3 minutes long, whatever. So this data is going to be considered quantitative. All right, and D part, zodiac signs of students in your class. So zodiac signs are non-numeric entries, but you can still separate these into different categories. So this data would be considered qualitative. All right, so hopefully you are following along in your notes and you have identified each of these and you understand why those are. If not, please reach out and ask questions if you're not sure about the difference between qualitative and quantitative data. Example 2, choosing and creating data displays. Analyze the data and then create a display that best represents the data. Explain your reasoning. All right, so A part says eye color survey. So they did a survey for eye color, and they have brown, blue, hazel, green, gray, and amber as the different colors. So the number of students who were in the survey that had brown eyes is 63. The number of students that had blue eyes in the survey is 37, and so on. So if we want to display this data, how would that be best displayed? So if you think back to what we've looked at, box and whisker plot and histograms, number lines, graphs, and things of that nature, this wouldn't really work very well because this is more of a qualitative data because we're looking at eye color. So we are counting how many of each have an eye color. So there are numbers involved, but it's not really, number data. So we're not looking at quantitative data. We're not looking at a graph to measure the numbers. We're just looking at a graph to represent the eye color. So in this case, you've probably heard of a circle graph. And in my opinion, a circle graph is going to be one of the most appropriate ways to display this data. So what we want to do is look at how much of the circle is going to be of brown eyes, blue eyes, etc. So we're looking at part of a whole. So the first thing you need to do is count up how many students total that we have in the survey. So if you add these numbers down through here, we are going to get a total of 140 students. So 140 students in the survey. All right, so now that we know that we have 140 students total that we surveyed to find out what their eye color is, now we have to decide how much of the entire circle each part should be shaded brown, blue, etc. So to find part of a whole, you simply have to take the part that we have. So we have 63 out of 140. Now, if we're going to make a circle graph, we need to multiply this by 360, because if you know anything about a circle, you know that an entire circle is 360 degrees. So what we want to know is what part of the entire circle is going to represent brown eyes, blue eyes, etc. So that's why we do 63 divided by the whole. That's the part of the data that's brown eyes. And then we want to do what part of that is going to represent the entire circle. So times 360. So that gives us 162 degrees. And all you have to do, if you want to look at this on the calculator, all right, so we're going to have 63 divided by 140, and then times 360. And that gives us our 162 degrees. So if you wonder where this number is coming from, I'm doing 63 brown eyes out of the 140 surveyed for eye color, and then multiply that by 360, which is what part of the circle is going to represent brown eyes. All right, now we're going to do that for each eye color. So we're going to have 37 over 140 times 360, and that's going to be 95. And that's what represents blue eyes. And then hazel is next, 25 out of 140 times 360, and that's going to be 64 degrees. And then we go to green. Green eyes, there's 10 people surveyed that have green eyes out of the total 140. Multiply that by 360, and we get 26 degrees. Gray, not many people have gray eyes. 3 out of the 140 surveyed. Multiply that by your circle, and 8% of the circle is going to represent gray eyes. And last but not least is amber. Only 2 people surveyed had amber eyes. So 2 out of 140, and then times that by the 360, and that's going to be 5% of your circle graph. Now, if you add these numbers here up, all those degrees together should add up to 360 degrees, which again is your entire circle. So now you can take a protractor and you can draw angles around to measure 162, 95, etc. So the first thing I would do is start with drawing a circle. Then you can kind of make the lines inside the circle that represent which portion of the circle represents brown, blue, hazel, etc. And then you label them from there. And again, I'm going to cheat a little bit, and I'm going to get this nice pretty graph that's already been drawn for me to represent that data. But again, remember 180 degrees is half of 360, so you can see that brown represents the biggest portion of the circle graph, which makes sense because it's the largest number here. Out of the 140, that's the biggest percent of the graph. And then 37 is the next largest, 25, 10. You can see these go in descending order, but you can see how each portion of the graph represents that percent of the entire circle. So when you're looking at qualitative data, a circle graph may be the best option. All right, going to quickly talk about B part. B part's up here in the corner. It says speeds of vehicles in miles per hour. For this is Interstate A and this is Interstate B. So this is talking about speeds. So the question says analyze the data and display and create a display that best represents the data. All right, so for this one, I believe I would use a double box and whisker plot. All right, so that would be an appropriate way to look at the data from these two tables. Remember to do a box and whisker plot. You need to do the 5-number summary. You need to find the least value and the greatest value. And then you need to find your median and your Q1 and your Q3. So you would need to do that for this set of data and do that for this set of data. And then, like in the previous example from the last lesson where we made a double box and whisker plot, you could do the same thing here. Since we've done a couple examples of the box and whisker plot already where I went through it step by step, this time I'm just going to give you the box and whisker plot here. And again, if you need a refresher on how to do that step by step, just go to the previous video and you will see how we found the minimum values, the maximum values. The median is in the middle, and then you've got Q1 and Q3 that fills out the box there. But for this set of data, I think this represents that data well. You can see the difference in the medians here. You can see the difference in the range, the highest number to the lowest number, and different parts of that data. So when it talks about analyzing data and explain your reasoning, there doesn't necessarily only one good answer. Sometimes there's more than one way to display data. And as long as you can explain that with good logic and however you display it represents the data well, and you can see how to answer questions about that data, then it will probably work. But that's this example. And if you have any questions, please let me know.